Right, 9 a.m. here in beautiful BC. We'll get started. Welcome, everybody. Thanks for spending the next 45 minutes, an hour with us. Today, we'll be looking at solving costly valve failures in pulp and paper applications with the DSS valves. If you go to the next slide, just quickly introduce the panel here. So we got myself, Braden Waters. I'm VP of Sales and Marketing with CJS, also sitting in as a Managing Director for DSS Valves International. Joining me today and the brain trust here was Kevin Niebergall. Kevin's been with CJS for 30 years. Worked out of our Prince George branch for most of his career and spent a lot of time in the pulp and paper industry. He now is our subject matter expert for pulp and paper and mining. So a wealth of knowledge, 30 years of experience helping our customers put the right valve into the hard applications. And then Sam Wynn, our marketing director for DSS VI and the genius that puts these on for us. So we love to share our knowledge and really with valve selection, knowledge is key to success. We will be taking you through some of the issues that we see in the pulp and paper industry and applications and how the DSS valve solves that. One of the things we love is the interaction and questions we get from our guests. So there is in the bottom of your Zoom window, there will be either the chat window or the question and answer Q&A box. Feel free to put your questions in there during the webinar and we'll try to answer those. If they're pertinent to the slides, we'll interrupt and ask that openly. We'll also have a few minutes at the end of this presentation to be able to ask those questions and follow up on anything else as well. So please feel free to interact there. And with that, I'll hand it over to Kevin to take us through.
Good. Thanks, Braden. Good morning and good afternoon, everyone. And look forward to sharing our knowledge, as Braden said. And to kick it off, this is the 100 years of knife gate valves. Knife gate valves are a category, so we've seen many subtypes developed over the years, engineered to address certain issues that the end users were experiencing. And when we look at this is the quest for zero leakage from the original design from the 1920s into generation 5 of guided shear gates today. One thing that we have seen is as we focus on applications and what is the right technology for that application, we've seen entry of other products from other industries where there are similar conditions, but the design of the product has not been successful. One in case is push through, and we'll see some of those in subsequent slides here. So conventional knife gate valves developed for the pulp and paper industry in about 1927 in Sweden. The first valves were designed to leak, and the dewatering of the pulp stock became the isolation point. But once you wanted to resume operations, you then had to deal with that plug. And there was many ways of dealing with it, either high pressure water, high pressure air, and it affected other equipment in the process. So we needed to find something different, but the knife gate terminology, this valve wasn't designed to cut. It was designed for positioning the blade because it was a unidirectional valve. And we'll touch on that in a couple of slides with real case examples. Through gate valves, they were developed to support the blade for vertical piping systems or to handle solids. In conventional knife gate valves that we were just looking at, they are pressure assisted design. They can be deflected by flow, by solids, by pressure that can affect their isolation performance and certainly their operation while it's in service. So through gates, we're now supporting the blade in the upper chest and the lower chest. And we can put it into vertical piping systems, or we can handle solids and high percentage slurries. And so it is the next evolution as you can see at the bottom, as we have on our quest for zero leakage. Line valves developed to provide a low-cost alternative to higher alloys. So we have a high alloy lining to it. We've also seen urethanes and elastomers used as well to provide some erosion resistance or abrasion resistance. And but we have seen the failures of these valves in service because of the wear of that liner exposes a very low alloy or low corrosion resistant material to very corrosive products or media. But it was the next evolution in the world of knife gate valves. Push-through valves were primarily designed for the mining industry for less than 10% solids and lower than 100 psi applications. But through sales forces growing, through a larger corporate owner, they were able to spread the push-throughs into a wide range of applications around the world, including the pulp and paper industry, where the design of it, because the blade pushes through the sleeve, creates an opening, and the valve is freely discharging into either the body cavity or the environment around the valve. So the latest evolution in the knife gate valve world is guided shear gate valves that have been around for many years. This is where we've machined internally the valve to fully guide the blade as it opens and closes, so it doesn't rely on pressure, where the predecessors, the majority of those are relying on pressure to seal. A guided shear gate valve does not. It is utilizing a perimeter seat that we'll get a clearer view of in a couple of slides here. But it was the latest iteration of a knife gate valve designed for slurry handling and high pressure applications. So in 2016, DSS entered the market with the Generation 5 guided shear gate valve, and had taken all the years of experience they have with guided shear gate valves, dating back into the 70s, to reintroduce or start from zero, from ground level, to redefine the guided shear gate valve. And there's a number of enhancements or design changes that they made with it to address many of the issues that we've seen with guided shear gate valves in the past, and improve the experience or the reliability of the valve while it's in service. So we have a number of different features in the guided shear gate design: non-rising stem, fully welded top works, internal radial seat or a perimeter seat that's always in contact with the blade because it is fully guided. The round port is unique to Generation 5. Others have body castings that are molded into the body or cast into the body to support the blade. So with DSS in Generation 5, we've widened the gate, and we've been able to utilize a full round port to minimize any type of points of turbulence and improve process conditions or parameters. Dust covers or safety covers protect that internal operating area. I should probably do this. Big thing here is the cap screws. Rather than a push pin or other way fasteners type, we're using a threaded cap screw that's stainless steel to hold that in place to protect it against any snapping or breaking where we would lose that benefit there. Transverse seals, we'll have a closer look at these, but that is one of the major changes in guided shear gate from initial designs, is a new packing arrangement that is adjusted from the side of the valve so that no one has to operate in the operating area or adjust any fasteners in the operating area of the valve. And these can be adjusted while the valve's in line under full pressure. As we look at solids handling or slurry applications. We have a Nyhard wear ring, and in the pulp and paper industry, we will find these on the trash extraction, the rock trap, those applications where we're dealing with a variety of materials, whether it's rocks, staples, other metals, but that will protect the valve body from abrasion and erosion. So what would the perfect isolation valve look like? It would operate easily from open to closed and vice versa. It would provide zero leakage downstream on a repeatable basis. It would not allow any leakage. It would not allow fugitive emissions. We'd have a very long service life with a low cost of ownership, so lower maintenance costs, etc. Again, easy to operate and readily available for short lead times. Here's a block diagram of the pulp and paper process. DSS guided shear gate technology will work in starting really rough from the impregnation steaming vessels through the entire fiber line process, through the bleach plant, around the pulp machine, but also in the recovery cycle on black liquors, white liquors, green liquors, whether they're clarified or unclarified. So a wide range of opportunities. One of the things that we'll touch on later, but we can also replace ball valves, wedge gate valves, plug valves with a guided shear gate technology because the product is ASME B16.34 pressure temperature rated from class 150 to class 1500. So a nice image of a pulp mill on a river, a variety of the application images that we'll see through this presentation. So issue number one, the wrong type of knife gate valve selected for an application. This is a slurry handling application with it's highly diluted, so it's primarily liquid. And as that push-through valve knife blade or gate cycles through the elastomer sleeve, that is spreading the sleeve apart and creating an opening where that media can fully discharge into the cavity. And many of these push-through designs require a collection system with piping that will collect that and move it to another area where you have to handle it. But in this case, we normally don't see that collection system implemented, and this is the result that we see in the field. Commissioning of some push-through knife gate valves. You can see that the spigots have flanges. They should be connected to piping so that in this event, we're not discharging into the working environment where we would expose people to risks or hazards. The image on the left is a black liquor valve, weak black liquor. That's again another push-through valve. And because of degradation of the sleeve material being an elastomer, we're seeing through leakage, but we've also seen the leakage building up in the valve cavity and affecting operation. So what's a guided shear gate valve? And it's a solution to many of the push-through valve applications. We have an oversized gate that has a slight flat and a bevel, and that is designed to create a shearing tip, or it generates a shearing tip or a fracturing point when the valve is closing. So if we're using it on raw green liquor or raw white liquor, where we see solids falling out of suspension and causing scale, this is what's going to assist us in overcoming cracking through that scale so that we can reach the fully closed position. And that bevel is going to push media away from the seating area. But it is the blade or the gate is fully guided by the body. In the upper left corner here, this is an internal flush port that's going to allow your media to be discharged downstream from the corners if any of that media is being pushed down through the gate guide to that corner area. It gives it a relief area to be discharged. And ideally, we have flow going through here. So through hydrodynamics, we're going to have a higher velocity that's going to assist us with moving media away from the sealing area. The primary seat is larger in generation 5, sorry. And as I said, perimeter's mounted, so it's always in contact with the blade on the edges. And then it is the primary body seal at the same time. And then in behind that, we have a secondary seal. The two-piece valve bodies, this is important if you have old facilities with where there's been shifting and movement within the structure. Piping may move with that, but this full monoblock construction increases the pipeline integrity of the system. So valves that are carved out that have two flanges essentially won't have the same structural integrity, and they can be twisted by the pipe alignment if there is any present. This little cutaway here at the bottom is just for the CNC tabs to lock it down on the machine bed, but otherwise it is a solid piece. So we can see the video demonstrating the shear tip. The blade passes within 1/1000th of an inch with the body. And so we have a shearing tip here to cut through a variety of solids and be able to get to the fully closed position. Examples of working on autoclave scale, some extremely hard process medias, and being able to push through that. So our video is not fully cycling through for us today, but let's get the idea. This is an installation that we observed at a British Columbia pulp mill where we had white liquor. This is on 2 white liquor pumps on their pump manifold, and they were using wedge gate valves that were very difficult to operate. Not only did we see that the scale buildup inside the valve was affecting operation, but we saw the stem leakage occurring as that shaft moves up and down through the packing. It's damaging that packing, and with sodium hydroxide or white liquor, it likes to find leak paths. So it will take advantage of those little tiny leak paths and lead to these stalagmites that we're seeing from the top of the valves. In the DSS Generation 5 design, no grooves, so we can protect that area, or we can eliminate any chance for the media building up. And with the shearing tip, creating that fracturing moment, we're able to essentially crack through the scale and reach our seat in the fully closed position. The 2 flush ports, if we do have the flow going through, will assist in discharging any of that media downstream so that we are freeing the seating area of debris. So another common issue in pulp and paper and other industries is leakage to atmosphere or fugitive emissions. Here's an example of conventional knife gate valve technology in an upside down position, but due to the design of the chest packing, which consists of square braided packing and a joint with an elastomer or other sealing component, we will see leakage, not only due to the joint, but also to compression sets. We're not using many elastic members for the chest packing, and it can allow leakage through the top works of the chest area of the valve. So square braided pump packing, designed for round shafts to seal on those, and those can be stacked. It has been used in knife gates where we cut it to a certain length, typically the length of the blade, or the width of the blade, sorry. And then we stack those by 3, and we have a gland follower that pushes on those square braided packings and the bottom of the packing gland to create interference on the blade. But in the majority of designs, we have a joint with the seat on the edge and the square braided packing across the face that is really, really difficult to seal. And that's why we see many conventional knife gate valves leaking from the chest area. So here are some examples. On the left, either a brown stock application or a black liquor application. We've got the black liquor discharging from the packing area and entering into the environment. On the right-hand side, the video is not running for us, but you might be able to see the droplets of water coming from this valve because it is leaking severely. Oh, now she's running. And we can just see in the top right-hand corner there, briefly, that it is fountaining up at the top. So it's going straight up and then falling below itself. So the dual transverse seals are the answer to address this issue with conventional knife gate valve technology. And it will consist of scraper blades, top and bottom, an elastomer C channel, and then the green portion is shredded PTFE, and that is compressed by the studs on the side of the valve, and those can be adjusted while the valve is in line under full line pressure without any issues, which I've personally done on white liquor and green liquor applications, and O2 delignification to eliminate any type of leakage to the top chest area of the valve. These are PTFE pucks, so to prevent metal on metal contact as the blade opens and closes. So here's a video on repacking a valve. If you've turned your studs in and you only have a few threads left exposed, you can add packing pellets. And these can be inserted. Let's give it a sec, see if she pops up. And we're not going to be so lucky. But the packing pellet can be inserted to the port. Oh, here we go. Just have to be a little bit more patient. And there, we're just compressing that packing through. It will push it through behind the transverse seal so that we can get 100% loading of the transverse seal across the face of the blade. Seat failures or liner failures is another significant issue within the pulp and paper industry. This is a example of a lined valve where the liner had failed and exposed a less or lower corrosion resistant body material and was able to eat away at the body. And obviously this led to a complete failure of the valve. And this was utilized in a scavenger service or a trash extraction service where we are dealing with high solids, contaminants of rock, staples, etc. That is also potentially going to damage liners and or seat materials. This is a image from a valve that has failed due to erosion, and the seat was pushed off the upstream seat, or sorry, it was pressed off the downstream seat due to downstream back pressure. And these tabs here interact with the bevel of the blade to deflect or push the blade to its seat. But because it was pushed away by downstream pressure, the leakage around and through that seat area caused erosion, leading to failure of the valve. Whereas Generation 5 guided shear gate valves are bidirectional. They do have a preferred flow direction, but they are bidirectional flow and bidirectional isolation capable. This is the upstream side of that valve's blade or gate, and we can see how significant the erosion was on the downstream side, and two potential issues could occur here. the valve was either installed backwards or a review of the balance of the application didn't indicate or wasn't learned that it could generate more back pressure or downstream pressure so that it would overcome the upstream pressure and flow backwards in the piping system. So it's always something to be looking at is what is your downstream pressure, what's your upstream pressure, what is normal, and what might be abnormal. To look at those factors to ensure that you're selecting the right valve product for the application.
Yeah, just to
Even as
interrupt for one sec. Sorry, there's looks like
okay,
there's a hand up in the attendees. If there's a question, if you just want to go into click on the bottom, there's a Q&A box there. If you click in there, then we can answer your question. Unfortunately, with the current setup, we can't let you talk or answer you directly. So if you have questions, just go into that Q&A section there at the bottom. Very good.
no worries, all good. It's perfect, thanks. So another example, this is a track extraction or scavenger application where we have a dump valve set up with the upper valve being open, the lower valve being closed, and they then alternate to discharge media that's been collected in the chamber into either a bin or a sump or however the system might be set up. And we can see the streams coming from the lower valve, and now we have the video acting and shows us what has been occurring with a conventional knife gate valve technology. And these were replaced with DSS guided shear gate valves, and we've eliminated that leakage and extended the lifespan of the in service. So primary and secondary seals in generation 4, or sorry, generation 5 is shown here, where we have the red is indicating the primary perimeter seat, which is also a body seal, and then the blue line is showing our body seal or our secondary seal, which is static inside the valve body. The faces of the body on either side have a pinhole drill that allows for mechanical retention of the seal ring. So there's little tiny holes drilled into the valve body and the valve seat groove or the O-ring groove that will lock that seat in place so that as the valve's opening and closing, it's not being pulled back and forth, putting stress on the elastomer itself. But if we should have, as the valve seat wears and loses some of elasticity, we still have a backup body seal to eliminate any type of atmospheric leakage.
Just maybe back on that, Kev. One of the things too, obviously, when we select the valve, we're aiming for longest life in service, but we do view these DSS valves as an asset and something that we recommend being able to repair and get back into service. And I think if you look at this image, you see the simplicity in the design when it comes to the sealing system. It's very effective, but it's also very inexpensive to repair and get back in the system. You've got the two body halves allow for easy disassembly. You got your two O-ring repair parts, and then the transverse seal that makes it very easy to repair.
Absolutely, couldn't agree more. And that's one of the, I guess, it's the word that I'm looking for, but the character or the ability of DSS with decades of experience in the machining of not only valves, but other components and other products. It's a very flexible product to configure for a variety of applications. In this case, we have wear rings that we can machine a shoulder into the valve. They are round, so they can be indexed, so they can be rotated as one portion of that wear ring wears. And we can offer either 17.4 pH stainless steel wear rings or NiHard, so very hard materials that provide wear resistance. But on a application with a cyclone effect cleaner, We can do breaker bars across that, so we stop any swirling action on top of the blade that would dish out the blade, and then we'd have failure at the chest area. So we can use the breaker bars to stop that effect and maintain the blade thickness so that we don't have any type of chest leakage. But we've also have close coupled them to pumps, and we put teeth on this wear ring to stop any type of circular swirling erosion of the valve bodies. So we've got a lot of flexibility in generation 4 and through DSS because of their background in machining to configure the valve. It's very modular, as you can see. We'll see in subsequent slides here. But Nyhard wear rings, low cost to protect the valve body from any type of abrasion or erosion in particular applications you may uncover in the industry. Topworks failures. So the topworks are really the chassis of the valve. If we wanted to make a car analogy, it transfers the power from the manual operator, gear operator, hand wheel, or the pneumatic hydraulic actuator or electric actuator. And ensuring that we are protecting it against corrosion, other stress forces is critical to ensuring that it provides that reliable, long service life. But we've seen this, I'm sure we've all seen something similar, and it's due to failure of the topwork. So here's an example of the top plate deflecting because the structure was not strong enough to transfer the power to the blade to push through the media. Whether it's and what we'll see in the pulp and paper industry is the green liquor services, the white liquor services will likely produce these type of situations where we need to use larger automation options or go to automatic actuation options with whether it's pneumatics or hydraulics. But being able to transfer that energy to the blade and through the media that we're handling is key.
I think this is probably one of the biggest, or not biggest, but one of the upgrades that DSS did with their Gen 5 guided shear gate is relook at the top structures. A lot of the previous generations and previous designs being invented a number of years ago, we're not considering some of the higher pressures and more severe services that we see today, and as a result, the engineering and the design that went into the top structure was really designed for manual operation and lower force pneumatic actuation. Today we see a lot more hydraulic actuators being used and double hung pneumatics for the higher pressures. And as a result, when DSS did their design, they really made sure that the top structure was engineered to be able to handle the higher forces of the bigger actuation and the hydraulics systems. So unfortunately, we see the bending and in some other designs, some other previous generations, as a result of trying to put an old design into current world requirements.
Yeah, and to Braden's point, you can see this is the top plate of a DSS Generation 5 guided shear gate versus Generation 4, where it's much thinner and it's deflecting because of the energy transfer not going, this top structure not being able to withstand those forces. So with the top structure through DSS, they've all undergone FEA, so finite element analysis, to ensure that the structure is suitable for the application that the valve is going to be developed for or created for. And that can vary from one application to another. But in general, the top structure that is standard has been designed for any of the applications that we would see in pulp and paper. So not a special non-standard design. Corrosion. Quite an issue within the pulp and paper industry, especially craft mills, not so much in our TMPs, BCTMPs, but in the craft process or in the bleaching process, we have potential corrosion issues that are significant, high level, and in and around a bleachery or a bleach plant where we're utilizing chlorine dioxide, it is a significant irritant that in severe cases can lead to pulmonary edema. So it's something that you need to protect the humans against. So through the enhanced engineered designs of sealing the chest area of the valve and the DSS guided shear gate valve, we can achieve that type of, eliminating the potentially fugitive emissions. In this example, not only is there a risk health factor to it, but we're starting to see this top works has been corroded by the chlorine dioxide. This would be a stock tower, chlorinated pulp stock tower. We see some flange gasket leakage here, but we can see the streams of the really salt cake that's coming out here. Crystallization of the chlorine dioxide. But the chlorine dioxide is eroding the top structure of this valve. So it is nearing complete failure. So we have replaced this valve now, but that's a full titanium 24-inch diameter valve. And the leakage is, as you can see, resulting on other corrosion points of the bolts, which needs to be addressed. So through the addressing corrosion, we have a wide range of body materials, gate materials, elastomers to offer. In the pulp and paper industry, we'll see some build designs shortly, but the most common for us are 316 stainless steel, Ni-resist, titanium, super duplex 2507. That'll cover the majority of applications within a pulp and paper environment. But if we need to look, we have options for others. But we are stocking those 4 materials that I've listed. Those are stocked in Michigan by DSS and readily available so that we can provide very short lead times with the right configuration in terms of corrosion resistance. Oh, I should also mention Xylan and Severe Guard, 2 non-stick style coatings that assist with lubrication and for automating the valve, but also the Severe Guard, similar design to providing lubrication, but a more wear-resistant option, sorry.
Hey, Kev, just a question that came into the chat here asking, is the guided shear gate DSS bidirectional zero leakage, and how do we achieve that? And then they asked about the tightness class for fugitive emissions as well. So maybe just do you want to chat on that quickly?
Yeah, for sure. So it is bidirectional zero leakage. We test to either ISO 5208 rate A or API 598 for the soft seat standard, where no allowable leakage can be witnessed. And through the perimeter seat, the guided position of the blade is always in contact with the seat from full open to full close. Can't be deflected by flow or pressure. It's considered a position seated valve rather than a pressure assisted seated valve. So we don't, whether it's 5 psi or it's 265 psi, we'll be in contact with the seat. The transverse seals, because we do wrap around the corners of the blade and also seal against the 4 faces, the 2 sides and the 2 front, the upstream and downstream, that eliminates any type of leakage that can occur through the top works. When we do seat test, we test to 110% of the valve's pressure rating because it's an ASME class 150 valve, meeting B16.1, B16.34 by ASME or ANSI. In stainless steel, we're rated to 265 psi. So we pressure test these valves to almost 300 psi in the class 150 product. and do a 1.5 hydrostatic shell test so that we can test the isolation performance of the transverse seals and then also the seating system itself. So the simplest question is we're always in contact with the seat. We're not pressure assisted, and we have the transverse seals that lead to our zero leakage performance. And in terms of fugitive emissions, can't remember the ISO. I knew it way better when I spent more time in oil and gas. But we got API 621, sorry, 622, 624, and 641 that apply to rotary and linear valves. But in the linear world, they apply to the gate valve style or globe valve style, where they're testing the packing. So we don't meet an ISO standard, but through the transverse seal, we are able to eliminate any type of TopWorks leakage and adjust that in line while it's under full line pressure.
I think that's maybe a good point to, because I'm sure there's a few people on the line here that have used the DSS in the past. One of the things we do, again, being an asset, we want the longest life in service. With the packing design, oftentimes we will back off the screws and adjust it roughly to the surface pressure. And so on startup, sometimes we may see a new valve that goes in that does see a little bit of weepage. And so we always recommend that on first install, once the valve is up to temperature, that you go in and give the packing adjustment screws a couple, maybe a turn or two to just re-energize it, get it up to temperature or up to pressure. If you overpack, it's going to result in excessive wear of that seal, and so you're going to have to replace the seals more often. If you underpackage, you see a little bit of weepage. So that adjustability is really good to be able to really dial it in and get the longest life on your packing design. And maybe just one other thing to touch on too. I think one of the pictures that we saw there, we had the two valves. One under the other and a lot of leakage. One of the issues with conventional knife gate valves is, as like Kevin said, they are pressure assisted in the sealing. And so if you look at any IOM for a conventional knife gate, it will say it needs at least 40 psi of pressure differential to achieve the allowable leakage that they offer. Anything less than 40 psi, the leakage rate is even going to be higher than what's allowed out of the factory. With the DSS, when you have putting these on a tank with only head pressure, we can achieve that zero leakage from vacuum to full pressure rating of the valve. So that perimeter seat really allows us a lot of flexibility to go into different designs that conventional life gate valves may have difficulty sealing with.
There was another question on how's the valve repacked. If you can scroll back to slide 15. Hopefully the video works this time. There you go. Yeah.
Yeah, so there is a reservoir of packing in the valve body, in the round port that connects or intersects with the groove that's machined into the valve body. The reservoir in the fifth generation of guided shear gate valves is a lot larger than previous generations. So you have more adjustability once the valve is received and installed. But as you turn in the packing, and you may have 3, 4, 5 threads exposed, there's still packing in the reservoir, but it's that's the point where you want to add another pellet so that you don't completely evacuate that port or reservoir of packing, so that you can continually adjust as you operate the valve. And I've seen valves that are in for 20 years that haven't had any packing adjustment. I've seen valves that have been in for 2 months and require adjustment. And it depends on how many cycles that valve is experiencing day to day. So if you have a high cycle application, you're going to be monitoring your TopWorks, your chest area more often, and perhaps adjusting it more often. But if you have an application, sorry?
You maybe go back to slide 16 there, the one with the internal view, that one there, yeah. with the internal view. Just for clarity too, the packet adjustment that we're showing there, that is adjusting the friction between the transverse seal and the gate, and that is what's eliminating any leakage to atmosphere. Your primary seal that's creating the isolation out through the valve, that is not replaceable in line. The valve would have to be taken out to replace that. But the flexibility and the design of the valve and the materials available, that's where we focus on selecting the right material to give us the longest life in the application. So in terms of seal materials in the pulp paper industry, AFLAS tends to be our preferred choice, but we have EPDM, Puna, Viton, FFKM. We've got a lot of different options that can really tailor it to the application. Urethane, if it's a more abrasive application, to really try to create a long service life with that seal. And the way that it's retained and held in the line, it's in parallel with the flow, but it is out of the flowway, so it's very well protected to ensure long life in service. Thanks.
So touched on this a number of times, but a strong top structure is key to transferring the energy. We're using an increased level number of bolts in the body itself as compared to previous generations where there were fewer bolts. This allows us to handle higher pressures, whether it's 750 psi for class 300, or it's 1500 psi for class 600. I won't go any higher because we don't see that in the pulp and paper industry, but we can build class 900 and 1500 for mining applications. This is where we have grown the guided shear gate technology and DSS into pulp and paper, is through replacing ball, plug, and wedge gate valves in a variety of applications, whether it's an MC pump that can generate up to 310 psi of discharge pressure, or it's in recost where we need to handle scaling media, and be able to operate within that realm. But you can provide some cost savings through the areas where they're using ball valves or plug valves. DSS becomes a very competitive product. So there's many ways to look at a pulp and paper facility. 30 to 40% of your knife gate valves are good candidates where DSS can and likely should be used. But the applications where ball valves or plug valves or wedge gate valves, that really provides you with additional growth of a guided shear gate into the pulp and paper facility. So talking about the bore revision or changes in Generation 5, we now have a full round bore versus the interior port guides that you'd find at the 3 and 9 o'clock position in Generation 1 through 4. This will minimize or eliminate turbulence, but also improve flow conditions, marginally in terms of pressure drops and CVs. Talking about that, we can configure these as control valves. So we do have inserts that can be sized, provide the characteristics needed for flow control. But we've used V notches in the past to create some back pressure or rough flow control for certain applications on pulp stocks. Standard builds for our common applications. Lion's share is stainless steel bodies with a Xylan coating, AFLAS seats, and transverse seals. We call it the pulp and paper build. So it's readily available. In chlorine dioxide and chlorinated pulp stock applications, we're utilizing Super Duplex 2507 and or titanium grade 2 with Xylan coatings and the AFLAS seat. And then when we look at the trash extraction, dump valve, scavenger valve, many different terms are used, grit pot cleaners, etc. Typically Nyresist with a Nyhard wear ring. perhaps a breaker bar in there with AFLAS or even EPDM seals will work very, very well. But we can also go to 17.4 for the bodies. The 17.4 gates are common because we need that hardness to withstand some of the abrasive solids that are present in those cleaning applications or even the staples that are present. But those would be our most common builds. So to touch on check valves, many check valves are problematic within a pulp and paper industry environment. As you can see, we have multiple components to this design with a disc, a shaft, and a hinge arm that's connected via a stud and nut. And because these are typically oversized, they do not fully open and they experience quite a bit of turbulence and vibration there where we see these backing off. But in this case, we've seen some deformation of either the arm or the pin itself, and we've lost contact with the seat. So we're not providing repeatable isolation through this design. External arms have been used to balance the discs because they're typically under or oversized. So we can use arms, weights, springs, dampeners on some check valves to control the position of the disc so we get better performance. But it does create a opening or a leak path to the atmosphere. And we can see these packing systems fail and result in leakage. Enter the DSS severe service check valve, where the disc is a machine plate, one piece of the shaft, arm, and disc. We do have a number of options if you're dealing with batch digesters where we can strengthen this disc because of the volatile action that occurs within those batch digesters. But this eliminates any type of breakage or that could lead to a loss of the disc. It's going to be an advantage in comparison to the traditional type of check valve. Retainerless body. So this is going to address any type of the external leakage. The body is one piece. We really have three components to it: a disc, a seat insert, and a body. And so very few parts, but the body is one piece. It has no openings in it. So the only potential leak path is between the valve flange face and the pipe flange. So a better image of all the components working together. We can size these, so we can adjust the inlet bore ID if it's a lower pressure application and we need to create some velocity. Velocity is one of the key things in a check valve. And that's why many of the check valves that fail, they're oversized and they're not creating enough velocity to fully open that product or that valve. So we've accounted for that with a venturi inlet, scalloping out the downstream side so that we allow for some pressure recovery. So we're minimizing pressure losses. We're increasing our CVs through it. It's a more efficient check valve than what we typically find in service today. So if you're looking at and with a short face-to-face dimension, easy to install. We've even installed the guided shear gate, the SV1, with the check valve on the downstream side, replacing a wedge gate valve. So we do have that option or offer available. Dual wound springs, double arm, which increases the stability of the disc and also gives us additional closing force as flow starts to diminish. It's going to start closing the valve. And this does have the rib, the backside rib, to increase the thickness so that if we're working with an application such as batch digesters where we see a real volatile action, this is going to absorb the stress and spread it across the blade so we're not deforming the disc itself.
Yeah, just want to give you a 5-minute warning. We got 5 minutes here before time's up. So we're almost there.
Thanks. Yeah. So a variety of additional options based off the platform, the standard platform from DSS. We have double block and bleed, where we have two blades through a single operator, and then purge and flush options available. Transmitter isolation, a full 3-inch round bore, so that we're competing against products that have a 1.5-inch bore or traditional knife gate valves. Same comparison. Square braided packing versus transverse seals, but this features a tank flange and ratchet handle. So here's a better image. So ratchet handle so that it'll be close mounted to a tank wall. So this side has a tank flange, and then you can adjust or install your transmitter. Flush ports are available so that we can wash the port area out. We've even had some clients calibrate their pressure transmitters through a closed valve and adding water pressure to the downstream side. So there's your tank flange on the right. Here it is in service beside a nice big guided shear gate valve by DSS. Block and bleeds, fully compliant to MSSSP 152, bidirectional zero leakage, full vacuum to class 1500. So you do see that we have, in this case, 8 studs. There's two transverse seals on the one blade, and then the second blade with a single operator. So it just gives you a nice image of the internals. You can see the flush ports. The ribbing that you see in that video or that image is chrome carbide. So that's been configured for a abrasive, erosive slurry application with the Nyhard wear rings inlet and outlet. Here's another good visual of the one-piece monoblock construction to give the body the structural strength for piping, and also for pressure. It's a pressure boundary. So going back to where we started off with what would be the perfect isolation valve. Here we see numerous DSS SV1 guided shear gate valves on a black liquor system at a pulp and paper facility. Zero leakage, zero hassle, zero mess is our goal.
Perfect. Thank you very much, Kevin. Appreciate the time. We've got a couple minutes here if there's any other questions. And I hear one popped in here now. Does the DSS check valve use a concentric disc, or is it a kind of disc or seat offset similar to double or triple offset butterfly valves?
It's a concentric design. It's an available soft seated or metal seated. In our metal seated configuration, we'll use a tapered seat that is mate lapped, and it has another part of that question.
Yeah, it's offset like a triple offset. So
Yeah.
no, it would be
No.
concentric, but it does being sandwiched between the two body halves. It does have a little bit of play, so that it can find its seat. A taper on the seat edge and the disc allows it to find that seat and surface and provide. Again, check valves aren't designed for zero leakage. The DSS out of the factory will be zero leakage when it's tested, but per API, check valves are meant to dissipate the energy and prevent the backflow.
As an option, we do have the tilt seat option.
Yeah.
So we have a shorter travel distance, more used in our severe service applications, and it can be spring assisted or non-spring assisted, but yeah, concentric seat design.
Perfect. Well, thank you very much. We'll end it there. But if there's any other questions, or if we have a ton of great install applications that happy to share with you guys. If there's particular issues you guys are having, please feel free to reach out to Sam or Kevin or myself or your local DSS distributor representatives. Sam will be sending out a follow-up email with a bit of questionnaire and some collateral. But thanks again for your spending the time with us. And if there's anything else that we can help with, please reach out. There's yeah.
There's one more question. Yeah.
Yeah. You mentioned you have valves for white liquor usage. Um, oh yeah, have
I think it's
usage of
liners.
liners to prevent buildup. Um, Yeah, it's a great question, David. We've got a lot of good experience with white liquor, and obviously with the scale build up, it's a challenging service. The couple features with the guided shear gate being fully guided, it does allow us to cut through the solids when we come into the metal to metal seating. We do have a specific procedure for white liquor applications, and it's really just opening and closing the valve a few times to break up that scale and refine the seat. So definitely in the pulp and paper industry, the white liquor is a harder application, but one that we've had very good success with the guided shear gate valve applications. And happy with that. Kevin had mentioned the Xylan coating. It's a Teflon based coating that we put on the body in the gate. It helps with the lubricity of cycling the valve internally, but it also helps with preventing some of the media from building up on the gates in the body as well. So it's definitely an option that we like to include. All right, with that, I got to jump off. I got a hard stop at 10 o'clock, so I'm a little late. But thank you for everybody. And Kev, Sam, thanks a lot for hosting.
Yep. Thanks a lot.
Okay, see you guys.
Have a great week.
Bye.